I'm here with Keerthana, a robotist at Google Deepmind, who describes herself on Twitter as being a mother of robots. So, hi, Keerthana, and welcome to the show.
Hi everyone.
Don't need to be
Thank
so
you for
close.
having me.
To be so close to the microphone.
Thank you for having me.
Um, so I think we can maybe like start with some questions about you, and then we can talk about your work. Yeah, what's your background? How did you become the mother of robots?
So I really liked physics in high school, and then I realized that a lot of physics in college usually means like quantum mechanics and stuff. But I really like things moving, like I like fluid mechanics and everything. And also, I think weirdly, when I was 17, I didn't want to like spend my whole life in front of a computer. So I did mechanical engineering, and then I started getting into machine learning around like maybe 2013, 14, when it was like getting big. So I learned programming by building websites with friends, and then robotics was like a very nice intersection of machine learning and mechanical engineering. So that's how I got in, and then I did a master's in CMU into robotics, and I worked for a bit, like a year in self-driving, and then I've been at DeepMind doing robotics. Yeah.
So roughly, it's been like 10 years since you like started being like interested in robotics.
Yeah. Yeah.
On your website, you said that you're interested, you're passionate about building human level self-improving intelligence in bits and atoms. Are you not afraid that like some self-improving system like self-improving AI could be like a danger to humanity?
I think there's a lot of literature on this already, but I also think that like safety fears are a little bit overrun, and this is my personal view. I'm not speaking for anyone else. And I also think I'm very optimistic about humanity's trajectory, and I also think that alignment is a practical problem that can be solved. So I'm optimistic about the future. Also, we are so far away. Like if you look at our SOTA models, they can barely do things. So I'm looking for ways to push forward our capabilities, yeah, right now.
Yeah, I think you talk about like our SOTA models. One thing like DeepMind released, I think yesterday, was Robotics Transformer 2, RT2. And for me, it doesn't sound like it's very far away. It sounds like it's doing a lot of things that we didn't think like robots could do like a few weeks ago or like a few months ago. Um, yeah, yeah, I'm curious, like, why, like, yeah, what's this paper, and if you can like present a little bit of the work, because I think you've done some of the work on RT2.
Yeah. So RT2 is a very simple idea. You train a model on the internet and then also on robot data, and now the robots can generalize to a wide variety of backgrounds. It can also like understand people, do a little bit of math, do symbolic reasoning. So it changes the way that generalization research has been approached before, and it gives robots with a lot of emergent and zero shot capabilities that were not previously possible.
Yeah, what are the kind of like tasks that it does zero shot, like the different like things you tested it on?
So these are all qualitative in the sense that if you repeatedly test it and if you vary things too much, they might not be robust. But qualitatively, I think we tested it on like three axes. One was symbolic reasoning. Second was like new objects, backgrounds, and stuff. And thirdly, also like human recognition.
Yeah, and on like symbolic reasoning, I think you said in the paper that it does like more like math things. Like, what are like some concrete examples of math? And are we talking about just like a model, or is it like a robot doing those kind of things?
Yeah. So, in fact, all of our data was like pick banana or like pick fruit or like move drinks from this place to this place, because it was initially trained as like a kitchen model. But now, if you train on the internet and then you ask, move banana to the sum of 1 plus 2, and then you put a 3 in there, and it can do that because like it learned that from the internet. Or like move banana to Germany, or give a Coke can to Taylor Swift, and it can do some of these things because it we never explicitly trained it on like who Taylor Swift is, like they trained the robot on, but just by being training by training on the internet, it is able to sort of stitch the robot trajectories with internet scale knowledge.
Yeah, I'm kind of curious about like the data, because like GPT-3 like a few years ago was like on the like Reddit links and like mostly text, and now we have like more like multimodal things. Like, did you train on like images and text at the same time? What was like the other thing? Is it like text and images, or
Yeah, it's text and images and also robot trajectories. So like actions.
how much trajectory do we have? Is like much like research groups like publishing their trajectory, or do we have like like where do we get this data?
So all of this data that was used for RT2 was collected by us. So that is actually one problem in robotics, is that it doesn't scale like vision language research, because you kind of have to collect your info, your data by interacting with the world. There are some ways to break it, which is like training on YouTube using like human manipulation. That would be one way to scale without collecting a lot of data. A second one would be like autonomous learning, but we are not like, these axes haven't like really given us a lot of benefit from pushing it. Yeah.
Um, yeah, you said that we were like very far away from like self-improving AI. What do you think are like the next challenges or like steps that like we still haven't solved that like seem very hard for like as a next step for like RT2?
So one would be definitely, I think, learning from human videos. The wealth of manipulation of 3D spaces and objects in the world is mostly in human body form. Like people making YouTube videos on like how to make an omelet or like how to do things. It would be amazing if we can like leverage all of that data and make robots like make omelets or play basketball or whatever.
So it's kind of like what Ethan Caballero was saying on one of the videos of like you train on all of YouTube and then like just from like all these like unsupervised data you learn like there's like demonstrations and not you don't have to have like those like robotic data. I'm kind of curious about the architecture because you said like it learns to do like move your arm to 1 + 1 = 2. So is it like a separate language model that like does this like math like 1 + 1 = 2, or is it like all in the same like network? Like how do you if the architecture is public like how do you what's it like robotics transformer like how does it work?
So, Robotics Transformer is actually the name for a very generic framework. It doesn't have to be one model. Like any VLM can be made into a robotics transformer too by sort of co-training it on robotic data. And so in the paper, like we showed with like two different architectures, one is Pali and one is PAMI. Pali is like it's already published work. You can look it up. Pathways language image model, and it has like a text encoder and image encoder, and then it learns things jointly. Yeah.
Got it. Yeah, I'm very excited about this paper. I'll probably like I need to read it more because it's been published yesterday. So today we're still in Hawaii. I think it's the last day of the conference, and I was at this workshop you were was I think organized by Encoder and other people. What was this workshop about? I heard you say some stuff, but I was like not completely understanding everything you were saying.
So it's called interactive learning from implicit human feedback. So it's like how can AI systems sort of like understand human preferences, ask for feedback, and incorporate that feedback into their learning.
I felt like there was like also some kind of like alignment component. Like people were like disagreeing about alignments somehow.
Yeah, alignment is basically human preference, right? Right now, the focus of the workshop was like more near-term work, but really pushing it into the long-term would mean alignment.
Yeah. How do you define alignment?
Getting a robot or an AI to do what the human wants.
Yeah, I think it's a good definition. And yeah, you guys were talking about myopia and aligning some reward function. And I don't know if you remember exactly what you were saying, but I feel like there were some people who thought we should like focus on like building superhuman models, and some people were saying that like the actual thing important was like to define well the goals, because otherwise the like that was the hard part, like having like clear goals. Yeah, I'm not sure exactly what you guys were saying, but do you remember roughly what was the discussion about?
I think, well, one discussion was about should we build superhuman models or not? And the second discussion was like how to give rewards for superhuman models.
And so do you think we should build superhuman models?
Oh, absolutely. Yeah, I mean, think about it, right? Like, look at how many people are working on important problems. Let's say solving climate change or solving robotics. Now, imagine if we have 100x brain power working on that, and maybe even like smarter beings. Also, there are comparisons, right? Like chimpanzees are intelligent, but far less intelligent than us, and but that means that they can do tool use and other things, but not like build rockets or go to space. So the next level of like if they were superhuman beings, they would unlock another level of capability.
So are you saying that like there's like a lot of problems to be solved right now with climate change and other things, and so we need to have this power to like solve this problem?
Yeah, I think we are kind of bottlenecked on how much cognitive power is available, right? And how much knowledge work we humans can do.
If you imagine there was like a skeptic in front of you or someone, what do you think would be like the best counter argument for why we should not build this kind of thing, like the best like stillman or counter argument?
I think there are some interesting arguments from the extras crowd, which is that once I think a lot of them are believable to some extent, in the sense that if there is a superhuman thing, then what would be our place in that society? Like, what? How can we be sure of the morals of those beings?
So how can we be sure?
I think that right now, like if you look at AI, there's so much coordination. And also, I think this is like really, really far off. And it's very hard to predict the future. And
How far?
superhuman AI,
Yeah.
well, would you call a calculator superhuman? It is kind of superhuman on
So-
one axis, right?
So someone that can do basically what everything you do right now.
I don't know, maybe definitely more than 50 years.
Okay. So you don't see yourself. Maybe you're
By
quite wrong.
everything, do you mean like digital things or also physical things?
Yeah, I'm talking to a roboticist. So yeah. I think only with online things you can do like a lot of things, right? If you could do like the remote version of yourself, you can like not go to meetings and you just have the AI version of yourself.
Yeah, true.
Um, and I think okay. So one thing I've seen on Twitter is that you're publishing a book. You seem quite young, but you're are already publishing a book for O'Reilly, ML for robotics. Yeah. What kind of like approach do you have? Is it more like LM in robotics, RL in robotics? What's the kind of ML you do?
Yeah. So the book is titled Machine Learning for Robotics. The main motivation is that robotics has kind of changed in the last like 5 to 6 years since deep learning took off. But most of the literature that we have on robotics is very classical stuff like control theory and everything. But the way that people do robotics today is very different, like RT1 and RT2. And there is nothing to bridge the literature gap. So the motivation of the book is to democratize the knowledge of robotics. Right now, in order to learn how these things work, you have to read a bunch of papers, gather knowledge like that, or go to conferences. But that's not possible for everyone. Yeah.
Cool. When is it going to be out if people want to?
Yeah, I mean, we are writing it in phases. So we release like couple chapters every month or so. Yeah. The whole book is like supposed to be done by March 2024. I want to go back a little bit to the point you made about will an AI be able to do everything that I can do? Um, it is not needed that an AI can do everything that I can do, as long as it can do a lot of useful things. Like this is the transformative AI definition. And I feel like this is more likely, people are more likely to solve problems that have higher economic value than just hard problems that don't have economic value.
So are you saying that we are going to get like transformative AI that is capable of doing like all the like useful work you do and like have GDP grow very very rapidly and everything changing very rapidly, but it will never be able to do like very weird things that human doing, like when they walk or they like.
Yeah, I think so. And yeah, I would even go and argue that maybe it's not even needed to solve all the types of different problems. In fact, like it's AI is already starting to affect GDP, right? With all these companies raising money and now also starting to take customers.
And are you excited about the economic price? Is there like a gradient or like a rate of growth that you think is like too high, or are you saying like any growth is good?
Yeah, I think growth is good. Do you think growth is, or like, do you think too much growth is bad?
I think if we're like developing AI and automating AI research fast enough that we're like not able to like understanding every like paper produced by if AI is capable of doing like AI research and people get very good at coding because they're augmented by their AI copilot, and at some point we need to be sure that the things we're releasing are going to be like aligned with preferences, and so we need at some point to like this like alignment work or this like safety work needs to like go as fast. And I think the rate of progress we've been seeing in like AI capabilities and like all these like different startups raising money is like much larger than like what other people are doing, and that's why I'm kind of concerned.
Yeah, no, that is a fair concern. I think it's true that safety and other things also needs to be similarly scaled in proportion. Um, it's happening though, right? Like you see that paper with the GPT, the mechanistic interpretability with GPT-2. It's kind of in a way scaling. I think
Like
AI is
how
going
many
to.
how many papers about like transformers or like AI capabilities that you see in the ICML compared to like the safety paper?
Rather few, but ICML is also a very theoretical kind of conference, right? Maybe NeurIPS is a more applied ML conference.
I think it's kind of saying. I think I've seen like maybe like in long term safety, I've seen maybe like 10 in like everything like robustness, distribution shift, etc. Maybe like 100. There was like 2,000 papers, so it's kind of rather small.
One of the other things is that like people who have exposure to safety stuff is usually industry, and industries are no longer publishing, but academia, it's actually harder for them to do safety work.
Well, are you saying like safety work like at big tech like Apple, Microsoft, etc. for like how to have language models like not say bad things? Or I think like the long term safety like AGI safety work is mostly public. People publish because it's like good to share it. But
Like I think now with like the commercialization of AI, the publication guidelines in like big labs have changed a lot, and so and conferences are right now I think a lot very academic heavy, right?
yeah, I think it's like just looking at the HTML, you don't get the full picture. Um, as a last question, if someone is watching this, like, do you have any message for like the YouTube audience that want to do robotics or interested in like kind of your work, or any message about AGI or alignment work? Or,
Yeah, I do have a message for like people who are interested in robotics. I think now is a great time to get into it. Robotics is like starting to scale and starting to see signs of life that we didn't see like in the last decade or so. So now is a great time even for like AI. People are often thinking that they are late to things. This is not true. Alignment is also a big problem that needs a lot of like new ideas. Yeah, great time to get in, read all the papers, like talk to people, reach out, and yeah, get contributing.
read all the papers and maybe in a few months read your book.